Hi students, today we are observing calculus. Okay, what is calculus? If you observe calculus, this calculus is is one of the branch in mathematics, right? So this calculus is the branch of mathematics that deals with the continuous change. What is that word? Continuous change. So continuous change is going to take place in this. Whenever you observe a continuous change, then you go with the calculus. Okay. So calculus is also called infinitesimal calculus or the calculus of infinitesimals. That means very small changes we are going to calculate by using this one. That is where the changes are going to appear in any kind of function, right? Suppose you are having f of x is one function. Okay. So what you do when you give some value to x, then f of x is going to vary, right? If you change the value of x in a wide range, in a wide range, then f of x also going to be changed in a wide, right? So like this, the meaning of this classical calculus is the study of continuous change of functions. Okay. So classical calculus is continuous change of functions. So most of these quantities or the functions, right? So we are saying that a small change or big change, whatever may be. Generally, we observe these things in the case of functions, right? Yes, functions. So in these functions of time, such as velocity is equal to change in distance with respect to time, like that. Okay. So that what are the two important concepts of calculus? The two main important calculus in concepts of calculus are derivatives and integrals. What are those? Derivatives and integrals. Yes. So before going to the derivatives, what is a derivative? So before going to the derivatives, let us observe the important term, the important concept, that is limit. So we are observing first limit and then we go with the derivative. Yes, very good. Now before going to the limit, you should know the neighborhood. You know our neighbors we have, right? Same. If you take what do you say, if you take any like number line I am taking. Okay, on this number line, let me take the number line. This is our number line. Also on this number line, okay, this is the number line. So this is 0 and this is 1, 2, okay, and 3, right, and 4. Let me take now. I am choosing a point. I am choosing a point to 2. Right. How can I reach the point? So I can reach the point in this direction, or I can reach this point in this direction. I have two directions, right? So that these two, in order to reach this point, I have either from either from right to left or left to right. So can you assume this as left direction, right? And this is right direction. Okay. Yes, very good. So now here you observe, whenever you say you are reaching the point correctly, here you are saying. But in the case of our limit, we are not saying that perfectly you are reaching the 2. Okay, just you are approaching the 2, we are saying. What do you say? You approach us to 2, or you are approaching to 2. That is the meaning. So in two ways, from left end, from left side you can approach, or right side also you can approach, right? So that is you are approaching to 2. So you are approaching to 2 means here also you are approaching to 2. So this right side when you approach 2, that can be called as, say this is A. Okay, you are approaching right side to A. So this can be assumed it as a plus. And if you are approaching to this end, so that is a minus. Like that we are going to take. Okay. Here A is the point if we took. So this is a plus and a minus. Like that we are going to meaning. So f of x is a function. F of x is a function. And if you are approaching to a, that can be represented as x tends to a. Tends or approaching to a. Okay. Approaching to a. So neighborhood here, what is the meaning? So you are not reaching the 2, you are approaching to the neighborhood of 2. Yes, you are approaching the neighborhood of 2. So what are the neighborhoods of 2? The neighborhood of 2 is either this end, right end, or right end or left end, right? So can you take this as 1.999999 so on, like this? Okay, 1.99. Or you can observe that this end, from this end you are coming. So 3 to back you are coming, right? So you are approaching 1.99 or 3.99 means you will go like this end, right? So what do you say? This is 2.990, right? 2.9999, right? This is 2.99. So this is again, what do you get? 1.9999, right? So this is 3, and before that you are going like this, right? So in this way you are approaching the any point, you are just approaching the point, you are not going to the perfect number or perfect point, either in a graph or here. Okay. Yes. Now in mathematics, you observe this limit can be defined as, because with respect to the function only we have to define, right? Limit. So this limit can be defined as a value that a function approaches for what? Approaches for the given input. So you are giving some input. Say, let us take f of x is equal to x plus 3 is our function. Okay, I took this function. So when I talk about f of 2, you can easily say that 2 plus 3 is equal to 5. 5 you are directly saying, right? But not in the case of a limit like this. So that means whenever even though you are giving, you are approaching to 2, then your f of x is approaches to 5. When x is, what is the meaning of this? When x approaches to, when x approaches to 2, f of x is approaching to 5. That is the meaning. Understood? Yes. Very good. Now, but here this is not the actual way of writing the limit. Let us observe clearly. Okay. Then you will get a crystal clear concept. Let me teach you the second important where you are using this limit. So limits are important in calculus. Yeah, you know that. And mathematical analysis used to define integrals and derivatives, right? I said. So derivatives, under derivatives, this limit is one first part. Okay. And continuity. We will study these later. Okay. In integrals, in integration, and as well as in derivatives. That is in differentiation also we are using these limits. Okay. It is used in analysis process and it always concerns about the behavior of the function at a particular point. Say, if I ask you, if I gave any kind of graph like this, so what is the behavior of this graph at this point if I ask? Then you can, by me using this analysis process, we can easily explain. Okay. Let us observe the graphs also step by step, one by one. Okay. In coming videos. Okay. Yes. So totally this limits are taking very important role in the case of calculus, right? Yes, very good. So now here you observe the neighborhood, right? So what is a neighborhood? What you said? the neighborhood is nothing but, this is the thing we are taking. Okay. In this, whenever you take, this is 1 and 2 and 3. So if you take a point, 3, so either you can approach from this end or you can approach from this end. So the neighborhood of 3 you are approaching. You are not directly approaching to the 3. That is the meaning. Understood? Yes. Let us move to the next part of limits and functions. Because what I said, only the changes are going to appear in maths. Generally, we are taking functions only, right? Yes, very good. Yeah, so a function may approach in two different limits. So one where the variable approaches its limit through values larger than the limit, right? I already said same. This is 3. So larger than the limit, right? So larger than the limit can be, it is a plus, right? So, and here the one which approaches from another end, from the other end. Otherwise, you take other end is a minus, right? So a plus, a minus. So two ways you are approaching to a point A here, right? So a plus and a minus. So here you observe the variable, that is the right hand limit of a function is the value of the function approaches when the variable approaches its limit to the right. So when it approaches the limit towards right, it can be called as a right hand limit. When it approaches towards left, it can be called as left hand limit. Understood? So here this can be represented as limit, can be represented as limit. Now we are talking. So LT we can write, or LIM also in some books. LT generally we are using limit. So where you are approaching, at which point, to which point you are approaching? You are approaching this A point, right? You are not going to that direct point. You are approaching. You are approaching to the point A. Yeah, very good. So now here you are approaching the point. That's why it can be called as approaching or tending to A. That can be X tends to A or X approaches to A. For what? For the function f of x, right? So this is a plus, right? So when you approach a, the value of this limit is going to be a right-handed limit, that is a plus. Got it? A plus. Okay. And similarly, when you approach limit x tends to a, f of x, this is a plus, right? So a plus, and here a minus you are taking. So this becomes a minus. So similarly, you can represent a plus and a minus. Okay. So this can be called as, actually here just I am explaining. No, this total thing can be a plus. This total thing can be a minus. So this can be called as right hand limit, okay, and this can be called as left hand limit, LHL, left hand limit, right hand limit. Okay, whenever these two limits are equal, RHL is equal to LHL, at that time only there exists a limit, right? There exists a limit. When the limit is going to exist, when RHS is equal to, RHL is equal to LHL. Understood? When RHL is equal to LHL, then we can say that the limit is going to exist, right? So now we will define the correct limit of a function. Come on. So the limit of a function exists if and only if the limit left hand limit is equal to the right hand limit, right? Left hand limit is equal to the right hand limit. So the limit of this function exists between any two consecutive integers, right? You can take either natural numbers, right? Or you can take any kind of numbers, whole numbers, like that you can take, okay? That means here, if you have, in order to, if you have two functions, f of x and g of x, okay, then if you have two functions, then you are going to add, you can subtract, you can divide, right? We have different algebraic operations, right? So how do we do those algebraic operations when we have two functions, right? If you observe here, you can observe, you can observe here, what are the limit laws. Before going to that, what are the laws of limit? Okay. So before going to the laws of limits, first, what is the necessity of these laws? So limit laws are individual properties of limits which are used to evaluate limits, because we if you want to calculate, if you want to calculate limit, then you have to go with this. To evaluate limits, we are using laws of limits. Okay. These are not only useful in the case in calculating limits, because calculators and graphs do not lead to the correct answer, right? Correct answer. In short, limit laws are formulas that help in calculating limits precisely. So, because by using calculators, we can't calculate any kind of, if I ask you sin x by x as x tends to something, means you can't calculate with the limit, right? Calculators. So for that reason, we are going to precisely, we are going to use it, because it has limit, has some laws or formulas. By using those, we can easily calculate the limits. Understood? Yes, very good. Now, let us observe what are those limits. Limit laws. Laws of limits. You observe. Sum of laws of limits. So, sum of, when you take sum for laws, sum law of limits, okay? So, the limit of a sum of two functions is equal to the sum of limits. Say, I am taking f of x is one function and g of x is one function, right? Two functions. Then I am taking the limits of these two. Yes, just I am adding, because sum we are observing. Yes, if you take the sum, what is the sum rule says is limit x tends to a f of x, okay, plus limit. So actually you are adding. So this will be totally equal to f of x plus g of x. You are adding, no? This is our LHS actually. I have written RHS directly. Okay. You see here, when you add these two functions, okay, with a combined limit, then you can take it as individual limits for individual functions. Got it? Yes, very good. Let us do one question for this. So you observe here, example limit of a sum. You see here. So this is limit as x tends to 8. Let us take x tends to 8. Okay. X plus 10. So this is one function, right? This is another function. Yes. Very good. So what you have to do? You can take the separate limits, right? For each and every function. Yes. I am going with that. Yes. Can I write like this? Depending upon this, some law of limits. Very good. So here, wherever you find x value, at that place you have to keep 8. Why? Because you are approaching towards 8, right? So directly you can keep 8. Yes. So limit x, wherever you have 8 at that place, you can put, wherever you have x at that place, you are putting 8. So 8 we got, no, the value of here, the value here is 8, right? So now plus, what about limit x tends to 8, 10. So 10 is constant, because here, is there any kind of variable or x? No. So you are getting the same 10, right? So 10 plus 8 is 18. We will study this constant, constant times function, because here directly constant, no, whenever you have a constant, simple constant, you can directly, you see here, limit, limit of any constant function is constant itself, right? I have written constant itself. Okay, so this is the way you are going to do the limits. Understood? Some law for limits. Then you go for difference. So how do you go for difference? Difference is also the same, no change. So here you do this. Come on, you try in your own way. Come on, limit x tends to 12, x minus 8. So can I split this one, right? So limit x tends to 8 and 8 x tends to 12. Sorry, x tends to 12 limit, and the function is, other function is, this is one function, this is another function. Okay, or constant function you can call it. Okay, this can be a constant function, right? Yeah, wherever you have x at that place, you are going to put 12. No need, because you are getting direct answer, right? And here, because it is a constant function, when you take the limit, you are getting the constant itself. So you are getting the answer as 4. Understood? Very good. Let us move to the next one. Come on. Limit of a constant. Limit of a constant. Just we discussed already. So limit as x tends to 7, 9 is directly 9. Okay. So limit x tends to 7. C is C itself. Okay. Limit x tends to 7. 9 is 9. Understood? Yes. Very good. Let us move to the next laws. What are the next laws? Come on, look at this. What are these laws? What do you understand? So the next law is product law of multiplication, product law. So how do we do the product law? You see here, limit x tends to 2. What is the meaning of product law? Limit x tends to a, f of x is one function, you are multiplying these two with a common limit. So you can take individual limits. Yes, can I take now here? So I am going to take, this is f of x. F of x is 5, right? G of x is x cube. In that way, I am going to split this total function into two parts, like into, no, between them, limit x tends to 2 x cube, right? So because it is a constant function, so you are getting 5 as it is into, and wherever you have x at that place, you are going to keep 2. So 2 cube is 8. 8 5s are 40. In this way, you are going to solve for product function. Yes, got it? Very good. And the next one, quotient law of limits. You observe the quotient law. How do we do quotient law? Quotient law also in the same way. So just you are splitting this limit to both. Can I split directly? Yeah. Limit x tends to 1, that is 3x in the numerator, by limit x tends to 1 and denominator. So how much you are getting? Wherever you have x at that place, you have to put how much? Yes, correct one. So 3 is our numerator, and here wherever you have x at that place, you are going to put 1. So 1 plus 5 is 6. 3 1 time 3 2 times 1. So half is the answer for this. Got it? Yes, very good. Next, to look at identity law of limits. So the limit of a linear function is equal to the number x approaching a. Identity law. Identity law. What is identity law? You know, whereas in the case of what do you say? 1 into a is equal to a. Normal. 0 plus a is equal to a. In the same way, you have limit x tends to a, x is equal to a, right? Because here x, instead of x, you are going to put a, right? So this is identity law of limits. Got it? Yes. Very good. Next, let us move to the power law of limits. What is power law of limits? So you observe here, limit x tends to a, f of x, whole power n. This is given, right? whole power n, which is given. So now, how do we write this one? So can I write this as limit x tends to a f of x, okay? And for whole, I can take it as n, right? Because here, what do you have? You have only for this function f of x, you have whole power n, right? So while taking the limit, there is no rule for this kind of thing. So if you have limit x tends to a f of x, we can do, right? So for that reason, I am going to write this function as like this by using our power law limit. Got it? Yes, come on, let us do one question. What is the question? Let us take one example. Limit x tends to 5 and x plus 1 whole square, right? So what you do for this? Limit x tends to 5, x plus 1. Can I put for this total thing whole square, right? Yeah. Now you can easily calculate the limit x plus 1 as x tends to 5. How much? So wherever you find x at that place, 5 plus 1, that is total 6, right? So for this whole square, right? So 6 square is 36. Got it? Yeah. In this way, we are going to solve all the questions like by using all these different types of, what do you say? What are these called? Yeah, these are called laws of limits. Okay, by using these laws of limits. Yeah. Now let us observe some special power law. Okay, what is that special power law? You see here, limit extends to a limit. Here you also limit extends to a x power n is equal to a power n. Yeah, simple, no, this one. As x tends to x power n is a power n. This is direct rule. Okay. Next, root law for limits. How do you calculate the root law? Come on, look at this. Limit x tends to a. Okay, nth root of f of x is equal to nth root of limit x tends to a f of x, right? So what do you do? Here limit x tends to 2 root f of x plus 14. So what you have to write for this? Yes. So root of, you can write root of limit x tends to 2. Okay. X tends to 2 f of x. Just you are removing the root and you kept the root here, right? So in this way, we can easily calculate limit x tends to 2 x plus 14. How much? How much it becomes? X tends to 2, limit x plus 14 is 2 plus 14, right? 2 plus 14. Yes or no? 2 plus 14. Yeah, 2 plus 14. That is the under root, right? So under root means root 16, which is equal to 4. Yes, understood? Very good. Next, linear function. Yeah. So linear function, you observe here limit x tends to 3, 5x minus 2. So simple, no? Limit x tends to 3, 5x minus 2. You can directly apply the root, right? Apply the 3 here. Let me write. So 5 into 3 minus 2, 15 minus 2, which is equal to 12. Okay, got it? Yes. Next, root special limit law. You observe root special limit law. What is the speciality under root? You see, n is positive integer and n is even. We assume that a should be greater than 0. Then limit x tends to a, nth root x. Nth root x is equal to nth root a. Okay, nth root a. Now, next we go to the limit composition. That is composition of limits. Okay, how composition means mixing. So at that time you have two functions, right? Yes, two functions. So now what are those two functions? Let us observe. Here you can observe the two functions are f of x, right? Limit x tends to a. Composite function of f of x and g of x can be written as, how do we write? f of g of x, right? So for this, we have taken a limit, okay, as x tends to a. Then how do you write? So function of, okay, function of limit x tends to a, g of x is equal to, g of x is equal to, or you can take limit, limit x tends to a, g of x is equal to f of a, right? Yeah. In that way, we are going to solve. Let us take one example of composite function. Then you will understand. Let us take limit x tends to pi cos x. Okay. So this can be written as limit x tends to cos pi. So cos, can I write this as cos? The function can be kept as it is, and you are going to keep the limit inside, right? So limit as x tends to pi x. Understood? Cos of limit x tends to pi x is cos pi. Cos 180 is minus 1. Got it? In this way, you are going to solve. Understood? Yes. Next, limit of functions. Normal functions. So what you do here? Let us do here. X tends to 5 to x square minus 3x plus 4. So directly we can substitute, no? Yes, correct. You are right. Plus 4. So how much you'll get? So 25 into 2 is 50. 5 3 is a 15 minus 4, that is 65 minus 4, which is equal to 61. Yes? Yes. So like this, we are going to solve. We are going to solve all the different types of all the losses of limits. So what are the limit laws? Let us observe. So this is a constant function, right? Constant function limit. Limit x tends to a, c is equal to c. Limit x tends to a, f of x plus g of x is equal to limit f of x, x tends to a, and limit g of x as x tends to a. And difference, so individual c we can take, right? So next one is constant times f of x, right? Constant times a function is constant you are keeping before, and then for the function you are going to calculate the limit, and then you are multiplying both together at last. Okay, and the product is also we are taking the separate limits to two functions, right? And in while quotient root quotient limit also the same thing, you are taking the individual limits, and whenever you have a power of n, then you can take the total limit whole power n, like that you are taking, and then this is the root of a function. The root of a function is nth root f of x, limit x tends to a is nth root limit f of x as x tends to a. Next, last one is composite function. What is composite function? That is f of g of x, which is equal to f of limit g of x as x tends to a, which becomes f of m, right? Okay, got it? Yes. Next, the last one is last limit x tends to a is a, limit x power n, limit x tends to a power n, nth root x is equal to nth root a. Understood? Yes. So these are our limit laws. Got it? So after going with the limit laws, today we are finding the methods to find the limits. What are the different methods to find the limits? The first one is direct substitution method. And in this method, you are the directly substituting the value in the limit. Okay, let us observe this method. What is direct substitution method? Come on. So here in this direct substitution method, when this can be direct substitution can be used. So with additions, okay, subtraction, divisions and multiplications and powers and roots, in all these cases we can observe this direct substitution method. Okay, now you observe limit x tends to a, A is equal to A, right? Limit of a constant is always simply a constant. You know that. And next, limit of x power r as x tends to c. That's why it is c power r. Power rule. Okay. Nth root x, nth root c. Right. And then limit f of x and g of x both exist. Then sum rule. Difference, product, and quotient. You know all these. Right. Let us take one example and we will do. Find the limit of f of x 9x minus 2 at x is equal to 6, right? How do we write this one? Let us write this one in our mathematical form. So how to write? Limit. What are they saying? They are asking at a particular point, that point is 6. At x is equal to 6. That means as x is approaching to 6, but in problems generally we are taking direct 6 because they only said that find the limit. So directly we are saying we are taking that the limit is existing. So we are taking x is directly approaching to 6. Okay. If they didn't ask like find the limit, or if they ask the question like this, whether the limit exists or not, at that time you have to go for right hand limit, right, and left hand limit. And then if these two are equal, then you can say that the limit is going to exist, right? In that manner, you are going to say. Come on, let us observe this one. So limit extends to 6. What is our function? So limit, what is our standard form? Limit extends to a f of x, right? So now I am writing away our f of x, that is 9x minus 2. Okay, this is our function. So now what is the first thing we are going to do whenever you have a function as x is approaching to something? So that x, whatever the value you are going to keep, right? So just substituting the value of x, right? How much you'll get? 54 minus 2, that is 52. So this is the limit. This is the value of the limit as x approaches to 6. What is the meaning actually? I will tell you what is the meaning, actual meaning of 52. What is this? So that means as x is approaching to 6, f of x is approaching. F of x means our 9x minus 2. 9x minus 2 is approaching to 52. That is the meaning. This should be clear. This is very important concept. As x is approaching to 6, our function 9x minus 2 is approaching to 52. That is the meaning. Got it? Yes, very good. Next, you take this ones. Find the limit. X square by x plus 3. X square by x plus 3. Limit x tends to 6. Right? So what you do? Simple, no? Just we can take the limit because this is a division, right? Quotient law we can apply. No need of writing every time. Just you can write it and you can do it directly also. Okay. So beginning so that we are writing, right? So now as x tends to 6, what happens? So 6 square by x tends to 6. 6 plus 3 is 9. So 36 upon 9, that is 4. 4 is our limit. That is as x is approaching to 6, okay, this function x square by x plus 3 value is approaching towards 4. That is the meaning. Yes, very good. So now I think you have a concept of this direct substitution method is crystal clear, right? Yes, very good. Let us move to the factorization and rationalization method. First, let us observe factorization method. The name itself says you know how to factorize the numbers, right? Sorry, no, factorize the numbers and as well as factorize the polynomials or factorize the any kind of functions. Yes. Let us take this one. So what is this? X square minus 25 divided by x minus 5. You know how to factorize the numerator. So, you know, if you do direct substitution, what happens? Why we are going for this method? That is the question, right? We can directly substitute it, no? Why we are going for this method? Let us observe in this example. So you see, as x tends to 5, what happens? What is the value you are getting? So 5 square minus 25, right? By 5 minus 5, what you are getting? 0 by 0 form, right? So you whenever is it possible to find the limit? So the limit cannot be defined. You can get the limit as 0, that is okay. But denominator never be 0, or this is indeterminate form, right? Indeterminate form. So whenever you get indeterminate form, in the case of direct substitution, you directly go for check for factorization. Yes, come on, let us do factorization, because direct method is not applicable in this, correct? Yes, come on, let us apply limit x tends to 5. Yeah. Yes, now you see here as x tends to 5, because you got 0 by 0 form, so you have definitely you have to factorize either numerator or denominator, right? So which one we are going to factorize? By observing this numerator, you are getting an idea that the algebraic rule, that is a square minus b square, we can write it as x plus 5 into x minus 5. Yes, any doubt in this? No doubt, very good. So x minus 5 cancel. Now you got our form type, right? Now you can directly use our direct substitution method, correct? Yeah. So what do you get? 5 plus 5, which is equal to 10. Yes. So you got the limit. So, right? So as x is approaching to 5, right? As x is approaching to 5, this function is approaching towards 10. That is the meaning. Very good. Yes. Now, next one is fact rationalization method. So, factorization method, sometimes it can be possible, but in the case of this kind of problems, rationalization, you know how to rationalize denominator and how to rationalize numerator, right? Yes. So in this rationalization, so what you have to do? Just by rationalizing it, if you rationalize it, you are getting a normal form, and then you direct substitution method. In that case, we can use. Yes, come on, let us do this. So what is that? Limit x tends to 0, root of x square plus 1 minus 1 by root of x square plus 16 minus 4, right? X square plus 16 minus 4. Yes. Now we are going to observe, if you put 0 here, what happens? If you put 0 here, what happens? 0 plus 1, root 1, 1 minus 1 is 0, right? 1 minus 1 is 0. And then here 0, root 16 is 4 minus 4 is 0. So you are getting 0 by 0 form. So this cannot be done by means of direct substitution. So you have to rationalize it. So how do we rationalize this one? So there may be a factorization and also rationalization, right? So how do we rationalize this one? This one, right? Let us rationalize this. Let me erase this one. This part I am going to erase it. Okay. Now, how do we rationalize? Let us rationalize the numerator. Okay. Let us rationalize the numerator. Numerator or denominator? So now x square plus 1. So let us, what do you say? Rationalize the numerator. So what is our numerator here? The numerator is, what is our numerator? X square plus 1. X square plus 1 plus minus 1. So what is the rationalizing factor? Rationalizing factor is root of x square plus 1 plus 1 is our rationalizing factor. Yes. So what you do, whenever you have like this, you have to multiply with its RF to make it to be rationalized, right? So I am multiplying with this numerator with rationalizing factor, that is x square plus 1, right? So whenever you multiply the numerator, you should multiply the with the denominator also, right? So come on, let us multiply with denominator also. What do you get? What you are getting? So this into a root of x square plus 1, okay? X square plus 1 plus 1, correct? Now come on, multiply. So when you rationalize this one with this, and what about denominator? Denominator is also to be rationalized, right? So what I am doing? Again, I am multiplying with, this is numerator RF, okay? Now, what about denominator RF? Denominator RF is, denominator rationalizing factor is root of x square plus 16 plus 4, right? Plus 4, okay? What I am doing? Just I am multiplying and dividing with the RF to make our denominator is also rational. Got it? Plus 4 divided by square root of x square plus 16 plus 4. Okay. What do we get now? We are getting, this is a plus b into a minus b, right? So a square. A square is root x square plus 1, root x square plus 1 whole square minus 1 divided by. So you observe here, these two are a plus b into a minus b. So that I am combining these two as a square minus b square. So root of x square plus 16 whole square minus x square plus 16 whole square minus 4 square. Got it? Into what is left in the numerator? Numerator is left with this one, no? Yes. So this thing into square root of x square plus 16 plus 4 into into x square root of x square plus 1 minus 1 plus 1 plus 1. Right? You got like this. So now what do we got? So this square and root get cancelled. X square and root cancelled. So it becomes minus 1 and plus 1 cancelled. So what is left? Left with only x square. So what do we have? X square into square root of x square plus 16. Okay, not whole root, no? Plus 4 I am writing, I kept big root. Okay. Plus 4 divided by, what you are getting again here? Because this is square and root cancel, and this 16 plus 16 minus 16 both are cancelled. You are getting only x square, right? So x square times, what is left? The same thing, x square plus 1 plus, is it x square plus 1 plus 1? Yeah, correct. So x square and x square get cancelled. So what do we got? So here I forgot to keep limits. Okay. You have to keep limits. Go on keeping limits. That is important. Okay. Here also you have to keep limit x tends to 0. Okay. Got it? Yes. This is our RFs. Okay. Come on. Now, wait. Now you see here, what do we get as x tends to 0? This is 0, right? So 0 plus 16 is 16. Under root 16 is 8 plus, sorry, 4. 4 plus 4, right? By here, x tends to 0 is 1. 1 plus 1 is 2. Yes. So 8 by 2, which is equal to 4, you are getting the value that is as x tends to 0, our function, this function is approaching to 4. Yes. Very good. Very good. Let us observe the next factorization and rationalization also done, no? Yes. Next, the main important theorem is sandwich theorem. So sandwich theorem says that sandwich theorem, this can also be called as squeeze theorem. Let us take the three functions. Okay. F of x, g of x, and h of x. Okay. These are the three functions you are taking. So whenever you take these three functions, if f of x as x tends to f of x is equal to L, then L and g of x and limit x tends to a h of x is also L, then g of x is also becoming the L. That is the sandwich theorem. That is, this means that g of x is sandwich between f of x and g of h of x, right? That's why. So because if it is L, if it is this is all, if these two are L, then automatically this is also L. Okay, that means g and h are real functions. We are taking g and h are real functions such that f of x should be less than or equal to g of x and less than or equal to h of x for all in the common domain of definition. Common domain means that is x, whatever the values you are giving x, those values should be satisfied for this inequation. Okay, satisfied for this for these functions. Okay, for all these functions. So whenever these are the functions like this you are taking, so for some real number a, for some real number a, limit x tends to a, f of x is equal to L, and limit x tends to a, limit x tends to a, h of x is also L, then limit limit g of x as x tends to a is also L. Okay, so you see, you can observe this graph also. This is our f of x. Okay, at the same point, right? At a only we are observing. Whether you are getting the same limit or not, in order to check that, you observe. You see, at point x can be taken at point A as x tends to A, right? So what happens to f of x? F of x is also having, say, at point, let us take B. Okay, this point. So f of x is also touching at point B. G of x and h of x, right? If f of x and h of x both are having the same limit, definitely g of x is also having that kind of limit itself. Why? Because the function is having the g of x is the sandwich of f of x and h of x. Okay, that is the reason you are getting the same value for limit for g of x. Got it? So by using this sandwich theorem, we are developing what do you say, some trigonometric. I am not proving this, just I gave a statement. That's all. Okay. Now let us observe. Basing on this, we are going to observe the standard forms of trigonometric functions. In the case of limit, okay, what are those standard forms? I am not proving, just I am giving. Okay, limit x tends to 0, sin x is 0. Limit x tends to 0, cos x is 1. Limit x tends to 0, tan x by x. These are very, very important. Okay, tan x by x. Okay, and sin x by x, and sin inverse x by x, tan inverse x by x. Sin and tan, x by x, always 1. You remember like that, easy way. Okay, tan x by x or tan inverse x by x, sin inverse x by x. sin x by x, all are 1. Now, limits of the form 1 to 1 power infinity. You take. Now, 1 power infinity means, you see, 1 plus x whole power 1 by x, right? So, this becomes what? E. Limit x tends to 0. 1 plus x whole power 1 by x is also E. Or just you reciprocal these two. Or you just reciprocal it. That is, this is 1 plus x, 1 plus 1 by x whole power x. This is also E. Okay. Not reciprocal. You mutually exchange these. Okay. Reciprocal is 1 by it. It is going to change. Right. Yes. Now limit x tends to infinity. 1 plus a by x whole power x is a e power a. Right. Because you are taking here, instead of 1, you are taking a. That's why you are getting e power a. This is e power 1. Right. Yes. Very good. Let us observe some more. What are those? You see here. What are those? We have limit. The next one is limit x tends to 0. E power x is 1. E power x minus 1 by x is also 1. Limit e power x. Okay, this is very important standard form. E power x by x as limit x tends to 0, which is 1. Okay, and a power x, this is also very, very important. Limit x tends to 0, a power x minus 1 by x is log a, log e, based log a to the base e here, not log 10. Why? In exponential, in logarithmics, in exponential forms, you are taking e as the base, whereas in common logarithms, you are going to take base as 10, right? Yes, correct. Next, let us look at this. The last two. Come on. What are those? Limit x tends to 0 log 1 plus x. Log 1 plus x by x. This is always 1. Okay. Next, the last and this is the law. This is not the last. This is not the least. This is, even though it is last, it is it is given a higher preference for all. Okay, what is that? Limit x tends to a x power n minus a power n by x minus a is equal to n into a power n minus 1. This is very, 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 very important. Okay. By using this, we are doing many, many problems. So wherever you see the limit problems, wherever you go, I'll be there like that. This won't leave you. Okay. So limit x tends to a x power n minus a power n by x minus a is equal to n into a power n minus 1. Actually, there is a proof also for this. I am not teaching that. Okay. Just I am going with this direct formula. Okay. So in this way, you have standard forms. Okay. That is reduction to standard forms. This is the other method. So we observed direct method, right? And then next, second one is factorization method, direct method, factorization method. And the third one is, what is the third one? Rationalization method. Factorization and rationalization both are combined only, but we can make it classified. Okay. The other one is reduction to standard forms. Got it? So standard, by using standard forms, we are going to calculate. Got it? Yes. Let us move to the next one. L'Hospital rule. This is very important rule. So this is actually related to the derivative. So f dash x means that is derivative. Okay. So this if f limit x tends to a, f of x by g of x is of the form 0 by 0, then you are going to apply L'Hospital rule. Okay. That L'Hospital rule, this what is f dash x and what is g dash x, those we will observe in derivatives. Okay. Just now we are going with limits only, right? Yes. Next, you observe How do we evaluate? First, we take this one. This one. Evaluate the given limit. Limit x tends to 0 sine ax by sine bx. Right? A comma b not equal to 0. If a becomes 0, what happens? So sine 0 it becomes. So it's infinite you are getting. B, if you put 0, 0 by 0 form you are getting. That's why they gave this condition. A comma b should not be 0. Very good. Now if you put x is 0, what happens? What happens? 0, x is 0. Then sine 0 by 0. Sine 0 by sine 0 by sine 0. Sine 0 is 0. 0 by 0 form you are getting. So what you have to do at that time? Yes. Is it possible to reduce? Is it possible to go with factorization? No. Right? Is it possible to make a change of a function? Any kind? Yes. Can you reduce by multiplying or by dividing or something? Yes, you can do. So how do we do? Say, I am writing this sine AX as I just am dividing with the AX and multiplying with AX. Can I do? Yeah, that is mass is giving full of rights. Mass is giving freedom to us, right? So when you follow my rule. What is the mathematic rule? When you multiply, you divide with anything. Okay? Yes. So sine BX by bx into bx. Yes, I am doing like this. Why I have written this one? Sine x by x limit x tends to 0 is 1, right? Because of this rule, because of the trigonometric rule, just we observed before. So because to get the given function in our trigonometric form, standard form, I am making it to write like this. You see, sine, this is x, no? X. This total thing is x. This total thing is x. This total thing is x, right? Sin x by x. So this becomes theta, no? Yeah, let me write that. So limit x tends to 0. Here you can cancel x and x, right? Yes, correct. So I am writing sin ax by ax into a, right? Whenever you have a constant function multiplied with constant, you can keep the constant before, right? So that I am transferring here. Can I transfer? Yes, very good. I transferred this one. Correct. Now, what happens? What about the denominator? Come on, think it and do. What about the denominator? Then the denominator is going to be, yes, that is also sin x by x, right? So here, this you assumed it as x, not power, okay? Don't assume that as a power because I have written x on the top, okay? Yes, sin x by x in order to tell the form x here so that ax is x and this ax is also x, like that I said, okay? Very good. So sin bx by bx. Can I put this one? So limit, because limit for this total limit, no? So whenever you have the total limit for numerator and denominator, we can take the limit, separate limit, no? Yes, correct. So limit x tends to 0. I am taking the limit separately. Sin bx by bx. Because this is a constant, right? X already I cancelled. Only b is left. Because constant times any function, I can keep the constant before. Can I? Yes, very good. So now what do you got? So limit x tends to 0, sin x by x, right? Sin x by x. So can I put this total thing as 1? Yes, very good. A into 1 by b into 1. Why I kept like this? So the total thing is sin x by x is equal to 1. So what is the answer? A upon b. Got it? Yes, very good. So in this way, we are going in different methods to calculate the different kinds of things like exponents, okay, and then like what do you say, rationalizing by using rationalizing factors you are going to rationalize the irrationals, and then calculating the limit, right? And trigonometric functions, exponentials, all these can be done by using these by using limits. You are finding the limit for different functions like trigonometric functions, exponential functions, okay, like that, constant functions, any kind of polynomial function, all functions, limits we are going to be calculated. Okay, got it? Yes. So in next video, we are going to observe the derivatives. Okay. Okay. Derivatives. What is a derivative and what are the things? Let us observe in the next video. Let us